Okay, in this video, we're going to look at an exiting case study for a large building here, and I've used this case study as an example before to some students to help them understand how exits actually work. So what I have here is a lower floor plan, so like a basement plan, a main floor plan, and an upper floor plan. Now there is more stories above this, but I've pretty much just taken the basement, main, and second floor for the purposes of this case study. And so what I've done on each one of these levels is I've highlighted the exit stairs. So there are, on the main floor, there's obviously other exits, the exterior doorways themselves, but what I've done is I've highlighted all the exit stairs in this building. And there's a couple of items in the code that we should take a look at here as to why these are exits or what's important about these exits. So one of them being the type of exit. So we're looking at an interior stairway, basically, which is very, very common. So an interior stairway is a type of exit. And secondly, the sentence here of the fire resistance rating of exits. So every exit shall be separated from the remainder of the building by a fire separation of some sort, basically. And so what that really tells us, it's not really direct in the code, but what that tells us is if you enter an exit, it is a safe zone. And like once you enter that stair on level 2 or 3, wherever you are, it's fire separated from the remainder of the floor, which means it's a bit of a safe area to give you some time to get out of the building. And so what that means is once you enter that stair, you should be in that safety zone until you actually get outside, in most cases outside. Except for this one article, which we looked at before, exits through lobbies. There's one situation there where you're allowed to have one exit stair go through a lobby. So this wouldn't be used a lot, like in smaller office buildings, you might see something like that. But generally speaking, once you enter an exit, you've got that protection from the remainder of the floor area, and you should not have to leave that exit and go back into the unsafe floor area to get outside. So let's take a look at this in the case study. And so knowing that you need to be in that protected space until you get to the outdoors, out of the building, it would make sense that those exits occur on the outsides of buildings, right? The exterior walls of buildings, like you see here and here. There's actually another exit right there that I need to highlight. And so then you might be asking yourself, well, why would you put exits in the middle of the building like this? Because now it's going to be hard to get to the outdoors staying in that fire rated space. So why would there be some there? Well, it's because it's a very large building. So probably the travel distance, say from a space here maybe to the nearest exit to there, maybe it was exceeded. So they had to put in more exits in the middle of this building to get people out of there so they didn't exceed the maximum travel distance. Also keep in mind that exits are based off of occupant load. So if you got rid of these 4 exits in the middle, let's just say the travel distance did work, and you got rid of those 4 exits, then these 4, 1, 2, 3, 4, would get twice as wide because the width of that exit would be based on the occupant load of that floor. So, probably it's the combination of both. I mean, probably it was a travel distance that drove having to add these exits in the middle of the building. But as well, it allowed smaller width of exits at the perimeters as well. And so if we looked at the exterior exits, basically, if we looked at entering the stair here and went down to the main floor, doors would open directly to the outside. For these 2 down here, for that one there, and for that one there. That makes sense because they're all on the exterior wall and very easy to achieve that. Now let's focus on these interior ones. Maybe we'll focus on a few of these right here. So let's take a look at this situation right here. Let's just say you are there's an emergency, you're exiting this building and you go to this exit. So first of all, you'll see the door swings in the direction of exit. Okay, that's exactly what you want. I shouldn't just say it's exactly what you want, it's exactly what's required. So you run into the stair and you go down. So the door has to swing in direction of travel, exit travel, and we're going to run downstairs and try and find a way to get out of here. So let's start with that stair. And now we're on the main stair and we're coming down the stair and we get down to here. And you'll notice on the main floor, the door still swings in, which means this exit's actually collecting people from this floor space out here on the main floor. To exit this way as well. So what's interesting here is you're not supposed to go out here. and again, leave the safety of the exit and enter the unsafe floor area of the main floor. And so what the intent is, as you come down from above here, the intent is that you go this way and you exit out right there to the exterior. Okay. Now, again, you can't leave the safety, the fire protection zone of the exit, basically. So what they've done here is they've created a corridor, and this corridor would have the same fire separation as that stair. And so what you actually have here, and you can tell, you know, if I dug into the drawings, there would be, in this building, it would be a 2-hour fire separation around the stair, which would be based off the fire separation requirement of the floor. So we'd have a 2-hour fire separation on the stair, and you'll see on this main floor, there's no wall here or door here, because this corridor now has become part of that stair, and that fire separation now is around this entire perimeter. So you are in that protected zone until you get to the exterior there. And now let's just go down to the basement and see what happens there. So same idea, here's that stair, and you know, you're in some space, maybe you're here, and you got to exit, and again the door swings in, and you're going to go up the stairs like this, up, 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 and you come out right here, and you exit out like that. Okay. So, you know, in this case, the stair is not on the exterior of the building, so you can't just have a door from the stair to the exterior. So they just increased the size of the stair, I suppose, in a way, or I just added a corridor to the stair that shares the same fire separation. And now that exit is, you're in that fire separation until you reach the exterior. And so that one's pretty straightforward, you know, in kind of understanding that idea of having to stay in the safety of the separation. Let's take a look at one of these other two stairs here. Actually, both of these are kind of important to look at. So we're going to look at these two over here. Now I'm on the main level here, so I'm going to start on the second floor again, and let's just take a look at what happens. Okay, so here we are on the second floor, and again, you know, we're in a room or whatever, and we have to get to an exit, and somebody's going this way, and they get to here. Again, the door swings in, okay, and we're going to go down those stairs. Let's just take a look at this other stair over here, and the same idea happens. So, you know, someone is exiting, and they end up going this way or whatever, and they get to here, and they're going to go down the stair like that, down to the main floor. So let's go down the main floor and see what happens. So we get to the main floor, and we'll just zoom on these stairs, and you'll notice something interesting again. The doors swing into the stairs on the main floor, there and there. Now, a lot of people would think, well, wait a minute, if I come down from the upper floors, I'd probably leave that stair to get to the outside. So this is outside right over here, and here's one of the main set of doors right there. So a lot of people think, well, it makes sense, I would leave that stair now at this point and make my way to the outdoors. But that's not the intent of that exit, because now you've left the safety of that fire separation. And a hint to that is that the door, again, isn't swinging that direction. It would have to swing in the direction of exit. And in that case, you'd be opening the door towards you. So you're not supposed to leave the stair. Okay, that's interesting. So let's see what happens on the lower floor. And again, there's more people collecting in here too, right? And now they're going to go down to the basement. So actually, on the main floor, they could just go to an exterior door in that building. But for the purposes of satisfying the building code and exiting, they have used this as one of the exits. All four of these they've used as an exit, that people are going to enter this stair on the main floor, and they're going to go elsewhere to get out of the building. And again, what drove that decision is probably travel distance. Again, if you deleted these, if not deleted them because you need them from above, but if you say you didn't have the doors here and didn't use them as part of the exits, then you'd have double the amount of exterior doors leaving the building, because again, it's based on occupant load. So anyways, the intent is that people will go in that stair from the main floor to get out of this building. And so let's take a look at the lower floor here, because you know if you go up that stair from the main floor, you're not getting anywhere. But maybe we get somewhere going down to the basement. So we go to the basement, we zoom in on here, and again, you come down from above, and you're coming down this way. And again, the door swings into this exit. So there's people still collecting through here. And what's happening here is, if you're coming down from above, you're just going around here and you're going this way. Okay, and if you're coming from over here, you're just doing the same thing. So you're going underneath the landing and stair above, basically. So there's enough headroom underneath this landing from above to get underneath it. And then you're going this way. Okay, so again, just like the other stair, to get you to the exterior, they've added a corridor that's fire, that has a fire separation that's equal to the fire separation of the stair. And you'll see there's no door there. And that's just because this corridor now has just become part of that stair fire separation. And now, so what I've done here is I've just drawn in orange here the extent of this fire separation. And so yeah, you come down this stair and you work your way down this corridor, and you'll work your way all on this corridor to right there when you get outside. That's outdoors right there. So that fire separation extends across that whole corridor. Now, there's something else very interesting about this corridor that's happening as well. And that is that we have this other exit stair right here that has to get connected to the exterior as well. So in this stair, they've done the exact same thing. They've attached a corridor to this corridor. And so you come down that other stair and you come down this way and you go into this corridor like this. So again, the fire separation of that stair has been continuous until you get to the exterior. So you have a bunch of people coming down this corridor here, and you got a bunch of people coming down this corridor here, and they're all entering the same corridor. And you'll notice the corridor gets wider. Not to mention that there's also a door into the corridor right here as well. So people are coming down this hallway and entering that corridor as well. And now, so the code requires, it's kind of interesting because for a stair, as the stair collects more people from each floor, you don't actually have to increase the width of the stair. So if you have a 40-story building, the stair stays the same width all the way down the building to the exterior, and the code allows that. But when you get into a horizontal exit situation, you have to increase the width of the corridor based on the occupant load. So as you add more people into this corridor, and from these other two exits right here, you've just maybe doubled the amount of people entering that corridor. So the width of the corridor had to double. So the width of the corridor, here, that width is based off the occupant load of people coming down the stair and the people entering from the lower floor in that door right there. So that width is based on occupant load of that. When you get to here, now you've added these people in, you've added these people in, and so the width of that corridor just got much wider. And then that logic continues as you come down the corridor here. The quantity of doors that you see leaving that corridor is based on required width, basically. So each one of those doors would be 915 wide, or 900 wide if it was metric, times 3, and that would have been the required exit width based on occupant load. And so let's just see where this is coming from in the code. So if we go to exit width based on occupant load, so that's been talked about in a different video, but that just pretty much tells you that you got to base the width of your exit based on the occupant load. So you would do that for your stairs or each level. But if you go down to exit width, it's this sentence right here, number 4. The required exit width need not be cumulative in an exit serving 2 or more floor areas located one above another. So when you're stacking those stairs, basically, it doesn't need to be cumulative, and that's why stairs don't get wider as you come down the building. Although I see it does have an exception to that, where you got to go to sentence 5, which seems to relate to assembly halls or theaters, and that takes you to sentence 6. So there might be some other stuff in that, but generally speaking, that's the approach. You don't make the stairs wider as you come down. And so the code doesn't tell you what you can't do. It just tells you, sorry, it doesn't tell you what you can do. It tells you what you can't do. So it's told us that we don't need to do that for stairs, but there's no sentence in here saying that you can't do that. You don't have to be cumulative for a horizontal exit. So that's why the horizontal exit has to be cumulative, and it has to get wider as you bring more people into it, basically. So there's no sentence saying you must do this. It's really well, there is a sentence saying you must do this, but it's really number 1, just saying that you got to base it off occupant load. So I guess what I want to say is there's no sentence saying you don't need to. So we got to do it. That's kind of how it works. So hopefully this little case study helps explain kind of the purpose of exits in buildings. And so I'll just end this with a couple of photos from this actual stair. So this is in the basement now. You come down the stair from above up here, and you come down and there's that corridor and you exit down this way and go down that way. Now you might notice like, wait a minute, what's all this garbage in here? It's like, yeah, that shouldn't be there. This isn't a storage room. So once I saw that, I immediately phoned the operations people of this building and said, you need to get that cleaned out. The width of this corridor is 100% based on the amount of people coming down that stair and entering from the lower floor as well into that stair or into that corridor. And now this is just looking down the other part of the corridor. So now this is a long corridor that heads to the exterior. So again, they've, you know, the width of this corridor was based on an occupant load, and they're storing stuff in there. So I phoned the operations people and I explained the situation to them. Just going back to the plan here, this is where the pictures were taken. So one was standing right there, looking down that corridor from, you know, and seeing that stair where you're going underneath the landing. And the second picture was looking down here. So if you go back to that picture, you'll see the double doors there in the background. And so if they didn't clean them out, you know, get rid of the storage out of there, what would I do? The next step would be I would phone the fire marshal or building inspector, someone like that, to get it formally, to get a direction formally sent to them saying you can't store stuff in there. So that's just a classic example of you know, an operations group that doesn't understand how exit design works. And, you know, in their head, maybe they're thinking, well, no, most people are going to exit through the main floor. And it's like, yeah, maybe most people will. But this is how it was designed, and that's the way it should be respected, you know. And a fire is one thing. If you have a fire on a third floor and everybody's leaving and they're exiting through the main floor because they feel it's safe, fine. But what if it's an active shooter and you don't know where the shooter is? You might actually want to use that corridor in the basement at that point. So, you know, you should really keep it clear for the amount of people that could be going down there for what it was designed for.